following is a conversation with Chetan Nageshpal, who was former MS student in computer architecture at the University of Massachusetts Lowell. Now, he is an embedded firmware engineer at Filtersense. Now, I present you this talk, which basically covers how the technology is growing and how a firmware engineering technology is being adapted in every field. Now, he talks about Docker, Kubernetes, and every other application that you can think about. So, this conversation is for you.
What is firmware according to you?
So usually there will be like application end, right? Like consider if you want to come up with any new designs for your day-to-day work. Consider you want to design a sensor or you want to design a surveillance camera. So everything has to be like it's an application. So in order for the application to work, you need to write some codes, and that code is like firmware. So which you write it and you dump it on a actual hardware, and the hardware does your work. So according to me, firmware is something which helps you accomplish an application that you're wishing for. Your audio is not audible.
What's your actual view in order to get the right firmware? That means what's your best hack that you are just going to do in order to learn about the client's requirements or else your requirement or else maybe anybody's. Let it be your, I'm asking you to write a firmware for my laptop today, which I'm inventing, kind of. So what will be your hack?
So yeah, it's the same like everywhere over here. So it's whatever we are building for the client relations, right? Like a client or the customer wants some specific task to be done for himself. So what we do is we take his requirement and we figure it out what actually needs to do and what technology that we have and what type of engineers we have to do those requirements. And we sit down and we have a meet like, okay, this customer needs this application to be done and what's its certain pros and cons. So, and we look into those things and we figure it out. Okay, this guy wants his sensors to be working at this speed. And for this speed to be working, we need to write a code in very like low level language because C is the most low level language that we can write. And if a customer is looking into just processing a data that is coming out from any server or a cloud, so we can write those code in Python. So Python is best to process data. So it depends like what the customer needs. If his action is like a real-time application, or he wants us to process a data that is coming out from any sensor or something like that. So it all depends upon what the customer needs. So understanding a firmware at the end of the day, it's about the customer need. So he wants to be working in a real-time application area, or just needs to be processing the data and putting out to the cloud. So that's how you come to a conclusion, which language that you have to write, which board that you want to use, which type of microcontroller do you want to have to work in those areas. Like consider if the customer wants a Bluetooth, then you definitely needs to find a chip which can support a Bluetooth. So it needs to have a Bluetooth GPIOs and Bluetooth processing application in it. So it all comes down to the customer requirement.
Let me just ask you one more question based on the customer's requirement. Like what makes an hardware for the function? That means you might be thinking of a torque sensor, which you recently built in a DJ component as an co-op. Now you are a full stack employee in a company where you are being not guided, but you are being thrown into a problem statement, which is just given to you. Tomorrow, let me just say, I, as an AI enthusiast, or else my institution as an AI company, let me just say an AI laboratory which comes to you. What will be your hardware? That means, will you use an FPGA and a GPGPU, or would you love learning new hardware and getting the client satisfaction? What's your hardware for the function?
Sure. So consider an AI example. So it's an artificial intelligence. It's all about data collection and improving its data, right? Getting the information from the previous node, building on that node, and canceling out the other nodes. So AI is all about data processing. So if any guy consider our instruments, we usually where I'm working right now, we usually come up with the particulate sensors. So and it just it gives the information about the particulates in an industries and getting gas chamber, all those type of things. So if some an AI guy comes into that particular company and he designs some AI codes or AI logic which can predict an alarm if the sensors are at this level. So what we can provide him with, like we will understand his requirements that he needs us to provide the real-time values and this much of data. So we look into a hardware which has more data, more memory in it, which can which can store a lot of RAM, because all the AI application, if any function happening in a real time, means it has to have a very good RAM. So we look into those type of hardware and we provide them with those solutions.
You have been talking about hardware because you are a firmware engineer now. So I always have this doubt, like what will be your expectation when you see a new intern or a new co-op coming inside your company, like under you or above you?
Sure.
What would be your first thing that you notice? Is it the way he codes? Is it the way he builds the hardware? Or else is it the way he solve the math behind an embedded system? What will be your first thing that you notice?
So yeah, usually I've conducted like couple of interviews when I was doing my internship too. So there was a couple of open positions that was available in my company, and they allowed me to do a programming interview for those things. And what exactly we look into it is just how he handles that particular situation. It doesn't matter which programming language he knows. He might be knowing any language, and we don't require him to know any particular language at that time. Consider I'm working in an embedded domain, so we wish him to know C or C++. But even if he's good at JavaScript or TypeScript, we are fine with it. The only thing is he needs to know how to solve that particular logic. So consider we tell him to solve a bubble sort or a quick sort or any Fibonacci series. So even he just has to come up with a logic how we will create an array, how we'll parse that array. So all we look into is how well and how fast he can solve that logic. So problem solving is the main thing that is look into it, because requirements and situations keeps on changing. So it doesn't matter which programming language he knows. It's always about how logically is strong and how well he can connect to how well he can handle situations, unexpected situations.
You have been saying like how we can handle the situation, how we can tackle an algorithm, basically. So like how sturdy is
Yeah.
algorithm today, and how sturdy is algorithm when they were being developed? Because when I see AlphaGo had an algorithm which was developed 14 years ago, the chip placements
Mm.
algorithms are being influenced by reinforcement learning today. What will be your only aspect? Like, should an firmware engineer be sticking on to one such algorithm, or should he just go out and explore a lot of algorithms? What do you expect when you're doing a research on one hand and you have client side satisfaction on the other hand? What are those factors? Is it the algorithm? Is it the hardware? Is it the software? Is it everything combined? At the end of the day, client satisfaction. What do you think?
Sure. Sure. So coming up with like an algorithm, it's always about you. It's not just if you consider if you know some like a quick sort. I understand you know a quick sort. So you can try to do everything in a quick sort algorithm, but you should make sure that the colleague of your knows too, right? Because at the end of the day, when you develop a code, you have to push the code to a server, a Git repository, where the colleague looks into the code and he understands how it is working and he gives you a feedback to it. But if you come up with a complex algorithm which he can't understand, it doesn't make sense. It doesn't help your future products too, because sometimes consider after a few years, someone has to come and look into that code. And if you can't understand your algorithm, it doesn't, at the end of the day, you failed in that thing, right? So you need to make sure that those algorithms that you come up with or those logic that you come up with should be able to understand, like everyone should get those things. So that is the main part of an using any algorithm. And it's not like that you have to concentrate on one particular thing. So as I mentioned, the API calls, everything changes. So it's always about your convenience. The more shorter the code, the more easier it will be for the review. You can use a loop to see some particular array, or you can just index one particular placements, and you can keep on just looking into its states. So it always depends upon how shorter your code is and how efficient, like time notation, it is called as O of n. So how fast you can get the information out of that loop or an array. So that is the most important part of it.
You talked a lot about how chip placement is being carried out in order to give the efficient results, and also more about things which hardware engineers has to focus in the real time. But Jim Keller always says that every architecture needs to be changed every 5 years. Like if today Ascent Xeon processor doesn't have the same thing, Kaby Lake, Whiskey Lake, Ice Lake, there are a lot of architectures which has been given out by Intel, and RDNA 2 version 2 and all these Vulkan drives and all these software and hardware is being changed from every company. Like, what's your view on Jim Keller's statement that we have to change the architecture, whether it's hardware or software, every 5 years?
As you know about the Moore's law, there's keep the transistors on a particular area keeps on increasing and like in an exponential manner. So if you see right now, all the big companies are working in a technological area about like 9 nanometers or 7 nanometers.
Even
So
3
whatever the
nanometers.
architecture,
Even 3
yeah,
nanometers.
3 nanometers. That's right. So it, as you notice, those architecture work were built when those like that was using 180 nanometers or some other those type of technology where the memory was restricted. So over the years, the transition development has increased, and people are using like pay to designing those new technologies in this 9 nanometers or 14 nanometer technology. There's like a lot of space for you to implement your another application in those areas. So right now you consider the new iPad or Mac, which Apple released day before yesterday. So what they have done is instead of using several chips on a single board, they have combined everything into one singular chip. So it just saved a lot of space and made their design so less lightweight. So that's the reason you just have to keep on changing your architecture, because right now we have a lot of potential that is available in those ICs. So we need to utilize those potentials.
Okay, now this is a lot of clarification because you talked about Moore's law, which is being growing exponentially every year, but someday it's going to stop one day. Let me just give you one more insight on as other law called as Dennard's law of scalability, which used to say that every time when per unit area the number of transistors are increasing. That's what it say. It's not in quotes. It's just a statement. Like every time when a memory cell comes out, VNAND, NOR flash or a NAND flash, anything, it tends to change the industry of memory. Doe Froman came with the EEPROM, and everything came out in a full stack fashion where everything was related to a silicon chip, which was an impure entity to a pure entity. Now it's going somewhere else. If I give you two options, would you choose between memory and the clock? What would be your first thing and first approach, whether to choose clock or whether to choose memory?
So as I mentioned, like clock right now, clocks are like way too. We can have a clocks which are way too very fast right now, but we are actually not utilizing the potential of the clock. So clocks are working at a way to gigahertz speed, right? But the GPIOs, the communications that we use, like to communicate between an IC to IC, it always comes down to like megahertz speed or a kilohertz speed. Consider all the I2C square protocol or a SPI protocol that you wish to communicate. Those are not matching up to the speed of the clock. So at the end of the day, the weakest link is what bringing you down those communications. So even you might have a clock speed which is of like 7 gigahertz or 5 gigahertz or 2 gigahertz. But at the end of the day, the communication between two ICs are happening through an I2C or a through SPI. its speed is just like 400 kilohertz or just 1 megahertz. So at the end of the day, clock is not influencing on your processing speed, because the IC communication is way too behind when compared to the clock speed. So I prefer going with a memory, so where you can store a lot of memory and you can utilize those memory. So I always choose on memory end. If you are having a device which has a lot of memory space to save, then it's much more easier, because clock is already developed ahead, and you're getting your algorithm function and everything way too fast. But since the communication between the IC is a backlog, so I prefer going with memory, having a good memory unit.
Like when you were saying I choose more of a memory, I had been reading a lot of Pentium processors because I was fed up of 8086 because it's purely an assembly thing. And okay, fine, it's not for me, boss. When I read of it, there are two things which really makes me okay. This thing, if it had not been done by Intel engineers under Vinod Dam's supremacy, it's not supremacy, it's basically his guidance. He has an MS in material science, but no related to the computer architecture. And like I see that there's two things like superscalar, two-way superscaling, and also L1 cache being first time deployed on the processor. Like it was a paper before, but now it was in a form of a deployment. L1 cache is on the processor, but L1 cache processor is fast. The bus frequencies are way more behind than what the speed was. Do you think that Pentium would have been enough if we had a compatible bus architecture?
Yeah, as I mentioned, like Intel has played an important key role in improving all the architecture and everything. Uh, yeah, and the Vinod Dham thing, yeah, it in over US, it doesn't matter which domain you are in. You can always change to whichever domain you want. If you see Sundar Pichai, he had done his master's in something else. Then he went to do an MBA,
Business,
and now
business.
he
He did
works.
his master's in
Yeah, and
material science business.
material science, and he is working as a different thing right now. So yeah, over here it's too flexible to change whichever you want. So yeah, all those like new technologies of having either the superscalar or L1 cache, it really, yeah, it is improving. So as I need to say, those type of situation is helping us to robust our architecture. So if not for L1 cache being on near to the processor, then it like all the artificial intelligence like the self-driving car and those reaction time would not have been possible. So I believe those more of cache near the processing, all those type of things, and the burst mode. It's helping us to go near to that artificial intelligence where the real time calculation is much needed.
Okay, because when you do real-time calculations, there are a lot of things which comes up because every time when they release a new processor, let it be 8051 which was being released or else an FPGA which was done,
Mm,
everything was not documented properly. But now documentations are available based on the hardware
mm,
because set of engineers have the leverage to communicate today. Olden days they didn't have it. But I'm just going to ask you one question, like how to read a data sheet. I know it's a very
mm.
simple, not a kind of a question which everybody asks in a podcast or something, but I just want you to answer this because you have been working in US for quite a bit of time and you have been experiencing how industry works. How to read a data sheet, and is it really making our life easier today? Because I see there are data sheets which are of this size no of no use to me because I use only a partial fraction of it. Will it make our life easier?
Yeah, I can give you like a good example. So when I started to do a co-op over here, so it was they gave me an Renaissance microcontroller. So it was way too new architecture for me. I never worked in Renaissance. So what I did is like, how do you get to know about a chip? So my manager had given me that he needs to do this type of application on those ICs. So I need to come up with all those type of particular APIs and the codes that is required for me. So of course, yeah, data sheet is the most important part of it. So what I did is like consider, he told me to enable few GPIOs on that Renaissance. So right now there's like a called as a cube programmer. In STM there's like a cube programmer, and in Renaissance there are eSquare Studio. So what it is doing is it's making our life way too easier. So it's like an GUI. It's a user interface where you come and enable a few GPIOs on in the program, in the application. Like consider you need to have a clock speed, and you need to enable this, and you need to make this GPIO and I2C. So what that GUI is doing, it's automatically enabling those things, and it's utilizing all the information in the data sheet, and it's providing you with those applications already. All you need to do is just write your logic inside it. So all those type of application is helping you to rely on the data sheets. But to cross verify, you do need the data sheet. Like consider the GUI has created a code for you, but you need to cross verify with the data sheet and make sure, okay, this was the reason this GUI has enabled. So is that the same thing that the data sheet mentions too? So that's how you need to correlate and you need to proceed. I totally get it. Like the as soon as you see the data sheet, it's always overwhelming. So, but if you divide like a page by page or a module by module, I think you can easily understand any architecture or in any ICs how it works. So data sheet is most important part of it. Yeah, I agree. You don't have to know everything about the data sheet. So it's always start with your core. So what the CPU can do, and start going away from the CPU. Okay, GPIO or the clock, and is there any enable pins that you need to enable? Is there any chips that you need to do? So all those type of things are required. That is the information you get through data sheets.
Like once I still remember that you had given me a data sheet of an RTOS.
Yeah.
I had also
That's
you had
true.
also gifted me an Renaissance chipset, which I really loved doing it because it took me almost a month to configure the IDE because I had to do the JDK.
Yeah,
I had
that
to
that
do the lot of dependencies before in hand. Like what makes an good RTOS? Like how to make a good RTOS? Like anything like related to RTOS. How can it be good? Because I see a lot of companies coming out with new approaches. Firmwares are getting robust these days because AI is getting the acceleration from the firmwares. It's not just the set of code which is being configured, or set of modules. What makes a real RTOS and most robust in terms of industrial application and also in terms of learning? Like as a new engineer, when you see an RTOS, you should never say एक घबराहट हो गई क्या हो गई मेरा जिंदगी में RTOS के लेके मेरा जिंदगी खराब हो रहा है.
yeah.
What makes
Sure.
a real RTOS?
Sure. So yeah, RTOS is nothing but it is utilizing your CPU's parallel processing, right? It's just like it's enabling you to do a parallel processing in a real time. So that is the main requirement of an RTOS. So for the main part you look into RTOS is how well its APIs are, what are the APIs that are available, because RTOS can have a lot of APIs like semaphore, mutex, those type of lot of things. So how many mutexes that are available, how many semaphores are available, and how many priority levels are that those are available in that, and is there any watchdog timer that can be implemented in those RTOS. So you look into those specific things, which is a minimum requirement for an RTOS. So that is the level 1 of an RTOS, and how well you can understand those APIs, because consider the free RTOS or so those type of thing has a very good APIs. So they are very well explained what this application does and how you can create a semaphore around it and how it operates. So when you are trying to go and search for an RTOS, you look in how well the data sheets are designed, how well you can understand those RTOS, and what type of APIs it can support, what type of applications you can implement it. So yeah, your requirement and they are available and how much they can provide to you, and will it satisfy your requirement. So these two things are the main you look into those things when you're looking for an RTOS.
Actually, that's great actually, because I didn't expect RTOS can be explained in this short fashion, because you actually answered two questions: how to make it more user friendly. I'll just ask you one question.
Yeah.
Like, do you think that RTOSs are not more reliable according to what OS is we are being using now? Because like, okay, I'll reframe this question. I'll edit this part, don't worry.
Yeah,
Like,
no.
okay, we are just using the RTOS now. We are also using a GUI based kernels which are being deployed in all our PCs and everything. But like when I see Linux, it's neither a GUI nor a shell script language or anything. You can compare it to anything. Linux has given you a lot of leverage because it has all the dependencies which an hardware engineers need. But most of the engineers don't tend to use it. What's your view on that?
Yeah, so consider the difference between an operating system and an RTOS. So it's about the memory and the processor, right? You are working on an RTOS in a way smaller chips. So it's just, but if you see the operating system where it is installed usually, it will be on a larger system. So it has more space, right? And it has more processing equipments added to it, ICs, all those type of things. So that is the reason you can implement a very big language like any operating system, like those Linux, everything in an operating system. And in the Nortos too, like right now, there is like all those Yocto Linux and everything. So you can just build an image on this type, similar to this type of ICs, which can support Linux operating too. So yeah, the main difference between RTOS and OS is the space and depend your requirement. And yeah, that's it. So it's at the end of the day, the Linux part, I agree. It's not everyone is very fond of Linux, but Linux is the way ahead. I've seen engineers over here who has been working in this domain for like 10 to 15 years and they never worked in Linux. So they always worked in yeah, they never worked in Linux. So even Linux is new to them. And yeah, it depends. Like for in my company, until like first year of my work over there, I never worked in Linux. So I always working in the STM environment. And so next 1 year, like right now, I'm working in all the Linux environment. And yeah,
Yeah, that's
Linux environment. So
actually
it depends upon the requirement. So few of the products change in my company. So currently I'm working in Linux environment, working in Docker area. So it always depends upon the what product you're designing and what requirements you need. So if your requirements are way too minimum, it doesn't make a sense for you to go to operating system or go to Linux. If it's way too minimum, you just can do your work with RTOS and NEC IDEs. That's fine.
like, let me just ask you one question straight. Comment on neural networks being deployed on edge devices like PSOCs, MCUs, GPGPUs. GPGPUs are not edge,
Hmm.
but yeah, they are trying to go to the edge. What's your comment on that kind of an environment? Like Adafruit is coming out with new architecture for, not new architecture, new set of hardware for neural networks. ARM actually supporting TensorFlow now. What's your view on
Yeah.
what can it take us to, like what can it really be in the industry of edge deployment? Can it really give away the computing aspect? Like I need an i3 processor minimum today. That will never be the case. I can use a Raspberry Pi and run an AI system, AI not system, and AI program into it. What's your comment on this?
Yeah. So yeah, it's I believe those are the reason that all those big companies are coming up with the product is the fact that it is the future. So that is the future. So if any company has to survive, they need to be compatible with what do you say, mm, with all the new 5G technology, everything. So whatever product they are releasing into the market, it needs to compatible with all those type of speed and everything, and all those type of AI intelligence in it. So I believe that is the reason like that. That is the future actually. If anyone has to have his field in any of this domain, then he needs to know about neural networking, artificial intelligence, and how all the TensorFlow how it works. So yeah, it's a way ahead, and there are every market in the south, like in the Silicon Valley, everyone is concentrating in this AI thing. So it's a very important part of future.
Like you have been saying that okay, AI can also be deployed on an edge. The AI can also replace today's computer. But like when I see Apollo, when I see sing satellites or maybe a rocket to the moon, uh, or else Werner von Braun saying that okay, this is not the set of thing which we are working, and he really just gave out new set of architectures for it. So what we have seen rockets being launched from ages. The set of hardware which they had used was not that compatible now, because we
Yeah.
don't even use it today, because a microprocessor in a phone is much more faster than the microprocessor which was used in probably Apollo 11. But like today's Jetson Nano is like a supercomputer on your hand, and Google has its own microprocessor board, not a microprocessor, it's a TPU board called as Coral. Like every company is intending to move towards edge, but they are not. What's your view on whether edge devices like Jetson Nano has to have a new enhanced feature, like anything which any of the microcontrollers or the microprocessor lack today? What's your view on the architecture which was used then and architecture which is used now?
Yeah, of course, in 60s, there was no computer at all, to be frank. There was just an ALU, arithmetic logic unit, which used to run, and we used to get an output out of it. So everything was designed on those ALU. There was nothing called as like a processor over there. So generation have come up, and there's a lot of difference when compared to Apollo products that I was used, and when compared to all the Jetson Nano. So yeah, so as I mentioned, even in spite of consider the SpaceX, they made their entire module to be touchscreen, right? Everything, if you see in there, all the new launches, the entire pod, the dock is just of touchscreen. But if you see behind the touchscreen, they have given all the manuals. So we can rely on the all this artificial, all this new edge technology and everything. But at the end, still we are progressing in those areas. We still need to have a backup. We still need to have everything that is working. So it's just like a push. So we are pushing it towards we're going towards a very good technology, but at the end you need to be able to support a plan B too at the same time. So whatever the features the Jetson is having or might lacking, so we need to come up with like another plan B. So we should not hinder the Jetson processing thing just because it doesn't have that type of specific communications thing in it. But what we can do is we can have a Jetson in front end and have a plan B, one more thing in the back, so we can support or in parallel operations.
You said Jetson has to have a backup now. Linux has been used since ages. Linux Trustfall just gave out the kernel, and it really changed the phase in which OS was being developed. So now at the end of the day, just comment me one thing. Not the end of the day, it's just end of the Linux thing. Is Linux secure?
Yeah, when you look into it, yeah, all the security applications that you're doing, either you go to Google or in my company, every secure product is developed in and around the Linux. So as you know, Linux has a very good kernel and all those kernel securities and everything. Everything has been designed in such a way that it can provide a much more safer, user-friendly experience. So yes, Linux is way too secure than compared to any other normal
Kernel.
embedded systems over there. Whichever units as an embedded system, if it has in Linux, then of course it will be way too secure when compared to other things. Consider like any other embedded system which doesn't have a Linux, you just have to go to a couple of ports in an ICs. And if an engineer hasn't come up with a secured way of storing the memory information, anyone can get out any information through that particular through ports. Any information you can fetch it out. So yeah, having a Linux, yeah, Linux is mainly used for security purpose. That is what I have to say. Linux is having a security as its advantage when compared to all other products out there.
Products out there. So now I have always been a fan of the Dharmendra Modha sir from Almaden Labs, IBM,
Mm.
and I've been following this research for quite a long time now. He's working on a true North technology, which is like one human and the Harvard architecture. It's nowhere related to that, but yet the chipsets are being used, and he himself is trying to design a new system which is like low power, mimicking the brain. Basically, the chip is trying to mimic the brain.
Mm.
As a firmware engineer, just comment about me with one question that I'm going to ask you now. Like, will we build a brain on the burning box, CPU? Or else is it really possible that the present architecture is going to make us a little closer, or a little closer approach in which we can really intend to build a brain on this burning box called as a CPU? Comment about it.
Yeah, I think the way everything is developing around the way the networking speed has been increased, so the decision-making speed of any CPU will be much more faster. It will be like light speed. That is where we are heading, all the quantum things and everything. So merging all those technologies from various domain, I believe that is possible in near future, where any autonomous system can take its own right decision what it needs to do. And yeah, I believe it's possible by merging all this technology right now, which is in still prototype or in pilot modules. And at the end of the day, like looking around to 10 to 15 years, you'll have a system which exactly looks into it, processes it, and puts out a result which a human brain can't imagine how it's doing, but it's possible. So if you see an autonomous driving system like a Tesla, it collects information from 360 point of view. It has all the information around it. So it fetches, it processes, and it takes a good decision better than human being can do at that moment. So I believe those things are possible in future. But at the end, yeah, there should be a human touch to it. That's how we can control these things. If it goes out of human touch, it will be way too complex for anyone to understand. So whoever designing all those type of has to make sure that there is a human touch for every whatever the products, AI products that are coming.
Like MIT has been giving out a paper saying that okay, machine plus an human will be greater amount of productivity. Now, autopilot from Tesla, it's nowhere related to machine and a human being combined together in a form of a fashion where we had a workforce which was completely humans, or else we now have a workforce which is intending to go completely a machine. And now MIT is coming out with that view of saying that machine plus the human being can give out more amount of productivity than autopilot has been telling that okay, there should be a driverless car at any given cost of time. So now, in fact, they are trying to build out such a system that it's trying to mimic the brain. They were in par with the Nvidia now, not in par with they were in partnership with the Nvidia for their hardware, but now they have only built their own FSD computer, a fully self-driving computer. What's your view on this massive disruption which really took place just for the self-driving car?
Uh, yeah, it's as I mentioned earlier for your one of the question, like autonomous is the future. Like whatever you do, you just it will be like you just sit in one place of a like in corner of a room and you want to do everything that is possible. So that's how we are progressed in the human history. If you see, like we try to make our life easier. So autonomous driving is a part of it. So at the end of the day, a person like Elon Musk came up with this like autonomous thing, which was on papers, and most of the big companies chains want to do it, but it was not possible. But he came up, he shaped that particular domain, autonomous driving domain, and he got all he tried to come up with utilize all such a new modern technology, and that is the reason the Tesla came up. So yeah, that disruption was needed, and yeah, once he has set a path, and let's see how many people will follow it. And those disruptions are much required. You always see a person in those areas, like one guy creating all these vibes, and everyone starts to follow that particular path. So that's how all this new technology has been built. Consider iPhone like an Apple. Apple was just it was normal computer when compared to IBM. But that this guy came up, Steve Jobs he came and he introduced his own style of designing it, user-friendly thing. There was a disruption in the computer market at that time too, right? The Mac stood out with an IBM. The way it looks, the way it processes, and the way it's just a tiny thing doing everything when compared to IBM occupying such a big space. So yeah, so those disruptions are good, and those technologies are much needed. Let's see how it goes.
Like you said, disruptions are needed. Now just comment about me with the last question of this podcast, then everything will be like okay. Everything will be on like
Mm,
how comment on the enthusiasts and all these kind of nonsense like that. Okay,
mm.
like just comment about me in this one question. What would be our life as an hardware engineers or software engineers or any engineer today is using a CPU today? So now what will be our life if Pentium was not invented?
Uh, yeah, we would have been lagging in all the technology that we have done. So there wouldn't have been in first place, there would have been not so much of engineers if not for the CPU. Yeah, there would have been no like huge manufacturing units if not for CPU processing such type of huge products. So yeah, it would have been a different world. If not for Pentium, it would have been there would have been something else. But yeah, if entire void of processor was there, then life would not have been. We would have not communicated right now. So yeah, it would have been a much different world if there was nothing like a Pentium. If there was something like Pentium, there would have been different. But yeah, the computer, the CPUs, and all those type of ALU units have helped us to come where we are right now.
Yeah. Thank you, Vicky. Thank you, Chetan, Nagesh, Pal, for this amazing podcast you gave for me. Always Vicky ne barate, bro. I am very sorry for that.
And
I always call him
it's not
Vicky,
an
so sorry, folks, if you guys want to really know his nickname. And it was an amazing talk with you that, okay, now we are at the end of it. We just have one thing to just say. Last question. Not tech, but yet for the hustle. What's your view on the present day enthusiasts who are really want to work in hardware industry, and what's your advice to them, and what they're lacking, and what's that edge they really have today and they're not utilizing it? Comment about it.
Yeah, so as since I did my undergrad in 2014 and did my master's recently, so I'm like just right out of my college days. That is what I can say. So what I believe is you can't concentrate on one single domain. So right now, when that is the difference between the Indian education and the education over here. So in Indian education, I did my undergrad in electronics and communication, but at right now, yeah, I do agree it helps, but there was no such markets out there which can provide a job in communication. So in India, there's like a lot of lagging in those R&D departments. So that's the difference between the education system over here and there. It in India, they made us to study just electronics, just communication. At the end of the day, it was not helpful for us to find a job in those hardcore core subjects, right? So it's very way too hard to get a job in the course domain in India. You need to be in like a top level, or you need to crack some government jobs to get into the core domain. So what I suggest over coming over here is expand your subject basis. So over here I did projects in network engineering. I did my projects in software defined networks. I did my project in embedded system, and I did my projects in operating system, robotics, and everything. So, and it helped me land a job too in a core industry. So when I went for interview, they were impressed for me knowing all those type of things. So that helped me to convince them why they should look into me and why they should hire me because I was bringing them the knowledge of networking, the robotics, and the software defined network as well as embedded system. So just you can't say I'm an embedded system, so I can only concentrate on C programming. No, it should not be like that. So know a bit about Python, which helps in you do network projects. So expand your horizon, and it will help you go into those industries which will help you grow your career.
Thank you so much, Vicky. Thank you so much. It was amazing talking with you. I think this is one of the best podcasts which I've done on air. Thank you so much, Vicky. Thank you a lot. Thanks a lot, bro.